Morning everyone. Today we're going to go through the Methodist Girls E-Math Prelim Paper 2 for all the Sec 4s taking the O-Level E-Math tomorrow, so all the best. Simplify this and express it as a single fraction in the lowest term. Okay. Note that 3 minus x squared is the same as x minus 3 squared, so I'm actually going to write this as 4 times x minus 3 divided by x minus 3 squared plus 5 over x minus 3 squared. If I expand 4x minus 3, I get 4x minus 12, so this is 4x minus 7 divided by x minus 3 squared. Simplify the following, leaving it in the positive indices. So y power negative 3 in the denominator is actually y cubed. So we get 2 power 6, 64 is 2 to the power of 6, x to the power of 6, and y cubed. And I'm going to raise this to the power of 2 over 3. So multiply each of the powers by 2 over 3. So you get 2 to the power of 4, x to the power of 4 and y squared, and 2 to the power of 4 is 16. So you have 16 x power 4 y squared. Solve the following simultaneous equations. Okay, let's make y the subject. So we have minus 1 over 6y equals to, bring over this 2/3 x, so you get 4 minus 2x divided by 3. If I multiply 6 on both sides, I get negative y is 8 minus 4x. So y is 4x minus 8. So if I substitute this into the second equation, I get 3x plus 3/4 of this actually happens to be 3x minus 6. So I get 3x minus 6 equals to 16, which gives us x equals to 22 divided by 6, which is 11 over 3. And what about y? If you solve for y, you will get 20 over 3. Because you can plug this into here, 44 over 3 minus 8. 44 minus 24 is 20. So 11 over 3 and 20 over 3. Of course, you can check the answers. Express this equation or express this quadratic in this form. Okay, so when we want to complete the square, we always want to get the let's put the 5, take out the 5 first, so that we get x squared minus 4 over 5x plus 7 over 5, or minus 7 over 5. And then we'll express this in the completed square form, so x minus 2 over 5 squared. Okay, and then we need to subtract the 2 over 5 squared, which is 4 over 25, and then the 7 over 5 as well, which is 35 over 25, so you should get 39 over 25, so minus 39 over 25, and then expand this, 5x minus 2/5 squared minus 39 over 5. Okay. And hence solve this equation. So we have 5x squared minus 4x. Now if we minus 9, we will get equals to 0, but we actually have a minus 7 at the top. So let's equate this to 2. And then do this. 5x minus 2 over 5 squared minus 39 over 5 equals to 2. And then we will bring this over here. So 2 plus 39 over 5 is 49 over 5. So x minus 2 over 5 squared is 49 over 25. So therefore x is equals to 2 over 5 plus or minus the square root of 49 over 25, which is, if I take the plus, I get x equals to, this is 7 over 5, so 9 over 5, or x equals to -1. Okay? So we get x equals to 9 over 5, or x equals to -1. Okay? A fruit basket contains 2 apples and 2 oranges. Second bag contains 1 apple, 1 orange, and 2 kiwis. Ben picks 1 fruit. Draw a possibility diagram. Okay. So there are 2. So I'm assuming they mean that both of them are like different containers. So apple. So there's a possibility that he picks a. So there's a probability that he picks an apple, and there's a possibility that he picks an orange. The probability here is 1 over 2, so it's half and half. Some of your teachers might actually teach you to not put it in simplest terms, to write 2 over 4, because there's 4 things in total. I think any convention works, so you can decide for yourself. And we're going to split this off into 3 branches. Now, the 2 branches for apple or an orange here are actually going to be identical because you are drawing from different bags. So you have a quarter, and half probability of pulling out a apple, and this is an orange, and this is kiwi. The same probabilities apply here. Oops. Apple, orange, and kiwi. Find the probability that Ben picks 2 apples. Okay, so from the diagram we can clearly see that it is half times quarter equals to 1 over 8. And what about different fruits? Okay, so we need to, he could either draw, so we use complement method, either he could draw 2 apples or 2 oranges, and then we change. Okay, so we do 1 minus 1 over 8. What is the probability that he draws an orange? 2 oranges. It's also 1 over 8. So using complement method is actually equals to 3 over 4. Of course, you can just add up all the possibilities. And it should be 3 over 4 as well. And at least 1 orange. So that will be the probability that he doesn't draw any orange. 1 minus that. So you can only choose, so the first one has to be an apple. So you take half, and the probability that he doesn't draw an orange. So that's 3 over 4. So you get 1 minus half times 3 over 4. Okay, so you get 5 over 8. So this is the probability he draws at least 1 orange. And you can verify this for yourself. If you go draw an apple first, you have a quarter probability of drawing an orange, so that's 1 over 8. And if you draw an orange at first, which is a half probability, doesn't matter what you draw after that. So it does add up to 5 over 8. Dream Renovation Company has 3 different packages. Okay, matrices. Okay. The unit cost price of each work is as follows. Unit represent, okay, 3 by 1. So that is just 180, 420, and 390. Evaluate QP. So that will be multiplying the matrix 6, 5, 6, 4, 2, 7, 5, 3, 9 by 180, 420, and 390. Now we have a 3 by 3 times a 3 by 1, so you will get another 3 by 1 matrix. So we will get 6 times 180 plus 5 times 420 plus 6 times 390, and you will get 5,520, and then you will get 4, and then you repeat with the other two rows essentially. You will get 4,290 here, and for the last row, $5,670. State what the elements of QP represent. Okay, so we have the number of quantity of each type of work multiplied by the cost of each unit. So it will actually be the total cost of each package, if you notice, because I take the plumbing work here and I multiply it by the unit price. I take the window work here, I multiply it by the unit price, and I do this for all of the rows. Okay, so it will be the total price. Okay, total cost from all the work in package A, B, and C respectively. Okay, a condominiums manager decided to engage the company to do that. 85. Okay, a matrix Y when multiplied by QP will give the total cost. So this is the cost per package. So you have a so this is a 3 by 1 matrix. You need a 1 by something matrix to multiply this. And in fact, you have 3 items here, so it will be a 1 by 3, right? So if you think about it, it will just be 85, 90, and 85, because when I multiply this together, essentially what's going to happen is I'll take the renovation cost for one package A and multiply it by the total number of package A I'm ordering, and the same will go for the other two numbers. Find the total cost. Okay, so this will just be 5520, 4290, and 5670. And then multiply this by 85, 90, and 85. And of course, you will just get a 1 by 1 matrix. And you can evaluate this product. Should be quite simple. You will get 1,337,250. So you just write down the number. It's a lot of money. Okay. Properties of circles. Okay. Angle AFD. Okay, let's see the diagram. Oh. $67 degrees, and this is 134 degrees. So that actually means, if you notice, E is the center of the circle, because angle at center is 2 times angle at circumference. Therefore, E is the center of the circle, right? So that is one thing we can take note of. And let's see. Actually, now that I think about it, oh wait, alternate segment theorem is not in the EMAth syllabus, I believe. Oh wait, no, I don't need that. I don't need that because I just need to take 180 degrees minus this. Okay, so angle, what is that, DEA? Equals to 180 degrees. Angles in opposite segments are supplementary. So therefore, 180 degrees minus 134 degrees. Okay, so that will be 46 degrees. Okay. And in fact, this is 46 degrees, and this is also 46 degrees. And this must also be 67, so actually we have a pair of similar triangles. Alright, so that's interesting. Although I don't think we need that. Angle CAD, so that should be, oh, well, I can justify that there's a right angle in a semicircle. So because of I've justified the above, therefore angle, actually I don't even need that in fact. I can use the fact that base angles of isosceles triangle. So therefore angle CAD equals 90 degrees minus 67 degrees, right? Because of right angle in semicircle. One can also use the base angles of isosceles triangle method. A line that has the same length as DF. Okay. So we can kind of see that DF, and we already proved that DF and AF, we kind of suspect that they will be the same length. And I kind of proved it just now, but I didn't write it down yet. And I will just quickly talk a bit about it. DF and AF, oh actually it's already given that they are tangents, what? Why is this, I don't understand why this is 2 marks and the rest is 1 mark, but never mind. AF, tangents from external point are equal. Yeah. Are equal in length. Okay. Explain why the center of circle I lie in the circumference of H. Circle 1 rather. Circle 1, oh. Oh, it lies circle 1 lies in circle 2. Oh, okay. You have to explain why. Okay. Well, its angle at center is 2 times the angle at circumference. So E is the center of circle 1. And it just so happens that it lies on circle 2. Okay? Because circumference of circle E is on circumference of circle. Two, but angle DEA, DCE. Is it DCE? Yes. Okay, so this is 67 degrees, which is 134 degrees divided by 2 degrees. Then you use the angle at center equals 2 times angle of circumference. Okay, so deduce that E must also be the center of circle 1. Show that BCG and DAG are similar triangles. Okay, so that will be this triangle and that triangle, which shouldn't be too hard because they have a common angle, right? And also because of the angles of opposite segments are supplementary, I can show that this angle and this angle must be the same. Okay. So angle BCG is common, or rather BGC, I think. Yeah, angle BGC is common. Then angle GDA, yeah, so angle GDA is 180 degrees minus CBA, right? Which just so happens to be 180 degrees minus 180 degrees minus angle GCB. Okay, and you can, oh, GBC actually, sorry. And we can check that for yourself. Okay, so GBC is this angle, yeah. Okay, because of equals to angle GBC, and for this is because angles in opposite segments are supplementary. Okay. The cumulative frequency graph, okay. From the curve, find the median. So the median will be, okay, so 160 chicks. So the median will be at 80. So this is, so each small square is a step of 5. So 75, 80 is here. Oh, this kind of lies in the middle. Does it? I think it does. Oh wait, it seems to be very close to this point. So I will take it as this one. Oh, I'm slanting my lines. Okay. I'll take it as that point, and I will take it as this line here. Okay. So this is one. The bottom one is in steps of 2, so this is 132. So this is 132 grams, and the interquartile range. For interquartile range, I'm going to need to draw the 40 line, which is here. And 40 is definitely in the middle of the square, definitely in the middle. So this seems to be 123. And what about the upper quartile, which is 120? So this is 40, this is 80. Now 120 is here. It's also in between the square, therefore so this is 143. I am making it a bit confusing, but it is between the squares, so therefore it is in the middle, half of the smallest division. So it's 143. Okay, so 143 minus 123. is 20 grams. So, okay, 20 grams. Given that 62.5% of chicks have mass more than X kg, okay, 62.5%, so this is 160 times 62.5% is, okay, actually this is 5 over 8, so you can get 100. So that is to say that 100 chicks have a mass of more than X. But you have to be very careful because this is a cumulative frequency. So if you want 100, you need to go 160 minus 100. So you need to look at the 60th percentile or 60 cumulative frequency. And you will get 128. So we read at 60th chick. Okay. Chicks that have mass less than 120 grams are classified as malnourished. 2 chicks are sent later at random. Find the probability that at least 1 chick is malnourished. So less than 120, we see that if we want 120, it corresponds to having there being 30, wait no, it corresponds to 30 chicks are malnourished, okay? So 30 chicks are malnourished. So we take 1 minus the complement, that both of them are not malnourished. So we take, there's 160 in total, so we get 130 divided by 160 times 129 divided by 159, okay? Which is probably not a very nice number. But you will get, wait, yeah, it will be 289 divided by 848, exactly. I think if you put 3SF, it also works, so 0.341. So I'll put 0.341, although I think they will also take the fraction 289 over 848. Yep. The box and whisker plot shows the distribution of the weight of chicks 1 month later. Okay. So you will see that the so how do you interpret a box and whisker? A box and whisker means that this is the minimum, this is the lower quartile, this is the median, this is the upper quartile, and this is the maximum. Okay, so the IQR, so this is steps of 2 again. So the IQR, so this is 138 lower quartile, upper quartile is 190, and the median is 172. So the median mass will increase. Average weight of chick increase because median increase from 132 grams to 172 grams. But the interquartile range here is 52, no, 52. And the interquartile range here is 20. Growth is less consistent in chicks after 1 month. Interquartile range increase from 20 grams to 52 grams. Okay, so you just say that one is more than the other. So bigger IQR means your data is more widespread, there's less consistency in how the chicks grew up. Yeah. Okay. At a bowling alley, okay, so seems to be quadratic. Patrick rolls a bowling ball toward the pins. Okay, 18 meters at an average speed of x meters per second. So time is distance over speed, so 18 divided by x. Patrick then picks up a second bowling ball and rolls it. Average speed of this ball is 0.5 meters per second greater. So that is it's still going to be distance over speed, which is 18 over x plus 0.5, which I shall write as 36 over 2x plus 1. There's a 54-second time gap between this Patrick rolling the second ball and when the first ball hit the pins. The total time taken when Patrick rolls out the first ball to the time when the second ball hits the pins is 1 minute. So we need to take note of the events that's happening. So let's take note of the events that's happening. So first ball, roll first ball, first ball hits, roll second ball, and then second ball hits. So this entire time interval is 60 seconds, whereas the time interval rolling the second ball and when the first ball hits, so that is 54 seconds. Okay, so what's going to happen basically is that the total is that in total this one is this part, how long does it take, the time taken for this one, because the first one will take a shorter time, the first one will take a longer time. So this is actually 18 over x, and this is actually 36 over 2x plus 1. So if we understand the question correctly, the total time will be the remaining 6 seconds. So we will get 18 over x plus 36 over 2x plus 1 equals to 6. Okay, and then we will cross multiply so that we get 18 2x plus 1 plus 36x divided by x times 2x plus 1 equals to 6. Sorry, no division here. Okay, so we multiply this so that we get 6x times 2x plus 1. We get 36x squared plus, we get 72x plus 18. 72x plus 18 equals to 12x squared plus 6. So one obtains the equation 12x squared minus 72x. Okay. Yeah. Yes, this is good. Oh wait, this is 6x. Sorry. No. 12x squared minus 66x. 18 equals to 0. So if I take out the so if I divide 12 by 6, I will get the desired equation: 2x squared minus 11x minus 3 equals 0. Very stingy 2 marks, I find, because you need to do the explanation also. Solve the following equation. Okay, so this is standard. So we use the quadratic formula. X is equals to negative b, so 11, plus or minus the square root of negative 11 square minus 4, 2, and negative 3, all over 2a. So simplify this. 11 plus minus, so this is plus square root of 145. Yeah. So then divide this by 4. So x is equals to, so you can evaluate the two possible values. So x is 5.7604, or x equals to negative, it will be a negative value, I think. You will get negative 0.2604. No, 40. Okay, so this is 5SF. So you leave my answer as 5.76 or negative 0.260. Explain why the solutions is rejected. X is the speed, right? X is speed, which should be positive. But we reject x equals to negative 0.26040. Okay? Or rather, so we reject this. How much longer in seconds does the ball take? First of all, hit the pins in the second. So we're counting the difference in times. So that will be. So what we need to do is find the value of. So the time taken will be shorter for the second one than the first one. So that will be 18 over x minus, actually I can plug in the values. So it will be 18 over 5.7604 minus 36 divided by 2 times 5.7604 and then plus 1. And this will give me 0.250 to 3SF. Okay. Question 6 is trigonometry. P, Q, and R are 3 points on the horizontal ground. Okay. So T seems to be like an elevation point, and so is S. PR is 50. Okay. We have some angles. Okay, find the distance PQ. Okay. So let's see. How can we find PQ? We have the opposite angle. We can deduce this angle. So angle PQR, we have to find angle PQR first because we have the opposite side being, we know that it's 50. So angle PQR is 180 degrees minus 85 degrees minus 38 degrees because the sum of the angles in the triangle is 180 degrees, right? Yeah. And we can find 180 degrees minus 85 minus 38. Okay. So we get 57 degrees. And we can now conclude that PQ over sine 57 degrees. And in fact, I can actually just add up these two and use that as sine because of the symmetry of the sine function, but it's fine. This is equals to 50. Oh wait, no, sorry. PQ over sine 38 degrees. That's the opposite angle. equals to 50 divided by sine 57 degrees. Okay, and then I can calculate. So you will get PQ equals to 36.705. So I'll put down 36.7 here. 3SF. Area of triangle PQR. So actually this should only be one mark, but because half AB sine C. So half 36.705, 50 sine 85 degrees. And then you can figure out what this is. So take this times 50 times half times sine 85. So you get 914.12. So 914. The greatest angle of elevation along the tower and viewed from a man walking along RQ. Greatest angle of elevation of the tower from some point on RQ. So if we understand the question carefully, we need to draw the dotted line here, and we need to see that I'll try and make this a bit more distinct. Okay, so we need to see that we need a right angle here, and to ensure a right angle, so we need this to be a right angle, and to get a right angle we need, let me call this F. Okay, so we let F be the foot perpendicular from P to RQ. From P to RQ. Okay. And then we can find PF. PF is just 50 sine 38 degrees. Which is 30.783. And angle of elevation is TFP, and we actually have a tangent angle. So tangent of TFP, opposite being the 21.2. So we have tangent TFP equals to the opposite, 21.2 divided by 30.783. So angle TFP, which is the angle of elevation, you can find the inverse tangent. You'll get 34.6 degrees, I think. Yeah. So you get 34.6 degrees to 1 dp. If the angle of depression from S is 20 degrees, find the height of the statue. Okay. So angle of depression of S from T. Oh, no, sorry. Angle of depression of S from T means this one. Means that this is 20 degrees. And I make this parallel to the ground. Okay, so angle of depression. Oh no, it's not this also. It's this. Draw this parallel. This is the 20-degree angle. Okay, angle of depression of S from T. The language is very important. So 20 degrees. Okay, so find the height of the statue. So one can see that TP sine 20 degrees, so this is 20 degrees. So one can see that, is it sine? Or no, I don't think so. It's oh wait, yeah, it is tangent. It's tangent. Because tangent of angle, okay, let's call this M, okay? So let M be a point above P. Let M be a point above P so that R, S, and PM have the same height, right? Same height. And then we're going to use trigo ratios, so we will get tangent, then MT is SM tangent 20 degrees. Eh? No. Is it the other way around? No, this is correct. Sorry about that. So TM is SM tangent 20 degrees. So SM one can find is TM, by the way, is oh wait, SM by the way is the same as RP, so 50 tangent 20 degrees. So one can find because PM and RS, so RS equals to TM minus PM, or rather, no, TP minus TM. Okay, RS equals to PM equals to TP minus TM. So essentially it is TP being the 50 something, or is it 21.2? Sorry. So it's 21.2 minus 50 tangent 20 degrees. Okay, and then you can figure out what this is. So trigo is always about the language of stuff. So you get 3.00 to 15, I'll put this. It's actually very nice. It's 3.00. Yeah, to 3SF. Okay, I'll take a short break and I'll come back to you guys in a bit. Alright, we're back. There's I think should have 4 more questions. Vectors. Given this, RS is this thing. Okay, so -1 and 2. The magnitude of RS is going to be the square root of -1 squared plus 2 squared. Right? So this is going to be just the square root of 5, which is 2.24 to 3SF. And find the coordinates of S. So OS is actually OR plus RS, right? OR is given, position vector means OR, so 3 minus 5 plus RS, which is -1 and 2, and then we get the -2 and -3. No, sorry, 2 and -3. Okay, so we get to write this in the coordinates form, 2 and -3. ABCD is a parallelogram with AF2FD. Express is simply possible in terms of A and B. Okay. Well, I really don't like it when they do not use O to refer to the origin. I do so much JC vectors until... Okay. EC... So... They are all similar triangles. Wait. ED is 1/3 CD. And AF is 2FD. Meaning that FD is 1/3 of AD. Okay, so actually these are the same ratio. So this is 1/1 and this is 2/2. It's the same ratio. EC is going to be minus 2/3 of A. EC, yeah. I'm not going to write reasons out for this because there's only one mark. DF, okay. DF is actually 1/3 of B, okay? Or rather, negative B. So take note of the direction of the vector. CA. CA is BA minus BC, which is A minus B. Yeah, that's it. It's A minus B. Okay. Are FE and CA parallel? Okay, yes, they are parallel. That's the answer. But why? Okay, so FE, so formally speaking, FE needs to be expressed as a scalar multiple of CA. So FE can be expressed as F. How should I go about this? Can I do FD and DE and compare it to AD and DC? Okay, FE equals FD plus DE. FD plus DE, and this is why does it look like a P? FD plus DE, which is 1/3 of AD plus 1/3 of DC. Which is, you can bring together the 1/3, AD plus DC is actually 1/3 of AC, which is equals to negative 1/3 of CA. Since there exists a real number K such that FE equals to KCA, they are parallel vectors. Okay. Calculate DEF over DCA. So similar triangle, so you just take the ratio, length ratio, you square it. So DEF, so like DF is 1/3 the length of DA, so it will be 1/9. Area of DEF over ABCD. Now you will see that the DCA is actually just half of the ABCD, so it will be 1/18. Yeah. All 1 mark questions, so I don't want to do too much explanation. If you're not sure about how I got these, just leave it in the comments. Okay, the figure shows a solid cylinder of height 26. Okay, so show that the height of the cone ABY is 35/3. Okay, looks like similar triangles. The height of ABY, and we're going to compare that to what other information do we have? We have the information 15, and this is equals to 26 divided by 27. Okay, so we have the height ABY equals to 26 over 27 times 15. Okay. Actually no. 21? Oh, 21, sorry. 21. I was confused because the 21 and the 26 arrows look very similar in length. Okay. And this happens to be 7 over 9. 7 over 9 times 15. Now this is 35 over 3 indeed. Okay. Calculate the length of YB. YB will be, we can use Pythagoras. So it is, we'll use 21 times, actually no. We have the height of the water already. So we use 35 over 3 times 15 over 2. So, or rather plus. So square root of 35 over 3 square plus 15 over 2 square. And this is 13.869 5SF, so 13.93 SF. The water is then emptied from the solid container. Find the total surface area of, okay. The total surface area. So the water doesn't actually matter lah, but the total surface area. So this container. Oh, so the container is like this part essentially, and they want us to find the surface area and the volume of it. Okay, so surface area will be the surface area, curved surface area of the cone plus the cylinder outside plus the circle at the bottom. So that will be we need to find dy equals to square root of, actually you can use similar triangles again if you want, but never mind, I'll just do the calculation again. So 21 square plus, 21 square plus 27 over 2 square. And this is 24.965 SF. So curved surface area is 26, so pi 27 over 2 square plus, okay. So total surface area will be the circle at the bottom, which is pi, then 27 over 2 squared plus the diameter times pi times the height. So the height is 26, so pi 27 times 26, I think. Is it? 27 times 26, correct. Oh wait, no, that's volume. No, it is correct. 27 and then height 26. Yes. Yes. Okay. And then plus pi, then the radius is 27 over 2. Then L, the slant height, is 24.965. Okay. And you will get 3840 3SF. Okay. The volume of the solid container will be the cylinder minus the cone. So volume of cylinder is 2627 square. Okay, so volume of cylinder will be pi 27 over 2 squared 26, which is 9477 over 2 pi. Volume of cone, this will be 1/3 pi r square h, so pi over 3, the radius is still 27 over 2 square, is it? Yeah. And then the height is 21. So you will get 5103 over 4 pi. So therefore, total equals to, you can just take this, 9477 over 2 pi minus 5103 divided by 4 pi. Okay, then you just figure out what this is. It will, oops. You will get 10,900 to 3SF. Okay. Energy is released during the breaking of molecular bonds. Okay, so this seems to be graph drawing. Find the value of P. Okay, so it's an exponential graph. That's interesting. So if you calculate the value of P, you will get 4 we're going to follow the thing and put, seems to be 3SF, I don't know, but I'm going to put it as 4.24, okay? Because it's a 3 times 2 to the power of 0.5. Using a scale of 2 cm to represent 0.5 degrees Celsius, draw a horizontal x-axis. Okay, and then plot the points. So let me get that on the screen. Okay. So we have to draw the grid ourselves. Minus 2 to 2. 2 cm represents 0.5. And 0 to 12. Okay. So we're going to try and position our graph in the middle. So let's see where that is. Oh, it's odd number. Okay, never mind. Okay. Let's put this here. 2 cm to represent 0.5 degree change. So that will mean that the graph ends over, so this is 1, 2, 3, 4. Okay, so the graph ends here. One, 2, 3, 4. Okay. And then to go from 0 to 12, you need to go up. 1, 2, 3, 4, 5, 6, 7, 8. Oops. 1, 2, 3, 4, 5, 6, 7, 8. Up to 12. Okay, so it stops here, and then yeah. Okay, so this is y, and this is x. Okay, so let me just plot the points. So this is this. So we need to actually draw the graph paper ourselves this time. Although in the recent O levels, I think they drew it for you. So this is minus 2, minus 1.5, minus 1, minus 0.5. This is the origin. This is 0.5, 1, 1.5, and 2. Okay, and then y, this is, okay, so, well, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get the idea. Okay, So we have all the points, and we're going to plot the points. So minus 2 is 0.75, which is 0. So it's closer to 0.8. So you plot to half the smallest division, so you plot this as 0.8. 1.5 is going to be it's a 1 cm to 1 unit, right? Just checking. Yep, 1 joule. Yeah, correct. Okay. So 1.5 is going to be in the middle here, so this will be this one. Let me just clearly mark each point. Okay. Oh wait, no, this is here. Sorry, this is a negative 1. Okay. At negative 0.5, it's 2.12, so you get to be somewhere here. At 0.5, it's 4.24, so that is somewhere here. At 1, you get to be 6. At 1.5 is 8.49, so that will be 8.5. We'll take it as 8.5, which is here. And 2 at 12, so that will be this one. Okay. So we have a very nice looking curve actually, because it's an exponential curve, so it's very nice. And we just need to join them with a smooth curve. Of course, if you're at home and you have a curve ruler, please use it. I don't though. So let's see what happens. Oops. I wonder why Microsoft Edge is doing adjustment for my curve for me. The curve should actually pass through the point 0.03, even though we did not get that point, because if you plug in x equals to 0, you will actually get 3. So it should pass through here. You should probably take note of that even if you don't have a curve ruler. This is very difficult to get this part up. Bit too high. My pen nib probably needs to be changed soon. And then no. I definitely need to change my pen nib. But you get the idea. Just draw a smooth curve. Yep, there you go. Okay. And I should probably label the equation. I think I forgot to do that for the Hawaii paper. Y equals to 3 times 2 power x. Okay. Okay. Use the graph to estimate when the temperature is 0 degrees Celsius. I mean, I don't even need to estimate this. This is just going to be 3. By drawing a tangent, find the gradient of the curve at x equals to 1. Okay. So that will be... Give me a minute. So if I draw a gradient at tangent at x equals to 1, let's see, how can I draw the tangent? Of course, they will accept a range of answers. No. Okay, so let's pick some points. Let's say I pick this point and this one. Okay, so draw your gradient triangle. Okay. Okay. So this is this seems to be 3.8, and this here seems to be 7.6. And down here this is so this is 0.45. Okay. And this is 1.6, 1.55 actually. Okay. So the gradient will be 7.6 minus 3.8, 1.55 minus 0.45. Okay. 7.6 minus 3.8, 1.55 minus 0.45, I think. Yeah. Okay. Which is 3.45. Yeah, 3.45. And the actual gradient, by the way, is 4.33, so I'm very off. It makes me wonder whether I did something wrong with the graph sketching. I mean, the difference in angle is only 3.15 degrees. Yeah, the difference in the angle that I calculated from the actual tangent is 3.15 degrees. So not much I can do about that. But the gradient is actually 4 point something, but I got 3 point something. So let me know if you guys can get close to the actual answer. The actual answer, by the way, is 3 over ln 2. For those of you who take AMAth, you will figure out how you can get the answer. But this, and of course, if you don't know what this is 4.3281, approximately. So this is the answer that you should be getting, but I'm getting a much lesser answer. So let me know if you can get the correct answer. State briefly what the gradient represents. It is the rate of change of the rate of increase of the energy, right? So rate of increase of energy released actually no, it is the increase per, it's not time, it's per unit temperature. So I should say increase of energy release per unit temperature when x equals to 1 degree Celsius. Yeah, that's what it is. Rate, you should usually reserve it for speed time kind of applications. Sorry. By drawing a suitable straight line, solve this equation. Okay, so 2x plus 1. So what I'm going to do is I'm actually going to write, I'm going to rearrange this equation. So if I divide by 2 on both sides, I can get this to be over 6. And if I want to get rid of the, if I want to get the 3 on this side, I need to multiply by 3. So I actually get 2 power x equals to x plus 4. Okay. So I think it's 1 mark for deriving the equation on the line that you need to draw, and then 1 mark for drawing the line, 1 mark for writing the answer. So x plus 4, so 4 is here, and you need to take note that this is minus 2, so you need to take note of the scale of the graph. So it seems to be 4 units length, 1 unit height. Oh, I overestimated because of the 4 being overestimated. So let me adjust that a bit. Okay, so it's here. have my lovely Microsoft whiteboard, I can do this so much easier. Okay. Okay, but you can kind of see that the intersection is somewhere here. And that is that's going to be slightly above. I'm going to say that it's just below, so I'm going to say that it's 4.6. Okay? Or rather, no, it's the y value. I'm going to say that the approach is, I'm going to say that the x value is here. Oops. Okay, so that is 0.65. Yeah. Although, oh sorry, it's a 3. Oh, I forgot. Yeah. I forgot. This is actually 3 times 2 power x. Sorry. Okay. So this is the equation solution for this is approximately 0.65 based on what I've drawn. Okay. You can verify for yourself that it is approximately a solution. 0.625 seems to be actually closer. So if you manage to get half the smallest division and slightly to the left of what I did, then that would be good. But never mind. I think 0.65 will also take it. Okay, so we've come to the real world context, which is another financial one. I believe many of the schools are spotting that this year's real world context will be a financial one, because last year's one was not. Last year's one was like building bridges or something like that. So, so Jane is planning a trip to Seoul. We have the price of the plane ticket from Singapore to Seoul, and assume flights depart 10 a.m. The flight time is 6 hours, and Seoul is 1 hour ahead of Singapore. I don't think they want that information here though. Okay, so I think they're just trying to say that basically it will be on the same day. Yeah. If Jane leaves Singapore one day, she will arrive in Seoul the next day, and if she leaves Seoul one day, she will arrive in Singapore the same day. I think that's what they're trying to say. Spend 6 nights in Seoul. Which dates should Jane depart Singapore? Well, you just want to take the lowest cost, huh? So I want the lowest cost to go for 6 days. So I would choose this, or I would choose this. So depart on 4th November and return on 10th November. Yeah. Price will be the price will be $990, which is the minimum for 6 days. For 6 nights. Because if I quote 5 to 11 north, is sorry, I can quote 5 to 11 November will be more expensive at 1303, 1,303. Okay, so basically we want her to save money, right? That is the assumption that we're going to make. What will be the total cost incurred for the flight and all the PCR and ART, because it's a COVID times, right? Throughout the trip, if she traveled on the dates, okay. Self-administered ART for those staying 8 days or more, so we are not counting this. Pre-departure ART within 24 hours of arrival. Okay, so oh, I should probably say actually I don't think it doesn't matter. Wait, oh wait, hang on a minute. Oh, I just realized something. If you depart on 6 November and you arrive, you're going to need to do a more expensive PCR. Okay. Also, PCR more expensive on Sunday than other days. Okay, I think that should be included also. You can quote the values if you want. Okay, so what we wanna is including all the PCR and ART, and this includes the one that you arrive again. So this will be this one. So this one is yes, this one is yes. We're going to take this one also, and we're going to take that one. And pre-departure, okay. So you will need 91 plus 106 plus 90 plus 15. Okay. So take this, this one, this one. And you need to pay for the flight also. So that will be $990. Plus all of the fees, which is 91, 106, 90, and 15. And then you can figure out what this is. Because this is including only the flight and all the COVID tests. Not including the hotel fees yet. There's no information on those yet. This is 1,292. No, 1,292, sorry. Okay. So this is the information Jane used to work out total basic expenses, 7 days, 6 nights. Tourist transportation card to cover public transportation costs. So how do we get the best deal for 7 days? Okay, never mind. We'll get into that later. Okay, so per day leisure. So we're assuming that she's going to spend all of this every day. And all costs are subjected to 7.5% goods and service tax. Exchange rate is this. Okay. Sensible budget in Singapore dollars. Okay. So she's paying for hotel accommodation. So hotel accommodation is 420,000. Equals to the 420,000 in Korean won. Leisure is, and you're paying this 6 times, you're paying the rest 7 times. And because everything is subject to a 7.5% good and service tax, I will actually be multiplying everything by 7.5% at the end, okay, for convenience. So this is that. Leisure plus F&B. So I take 57,000 times 60,000 and I multiply, sorry, plus 60,000. And then I multiply this by 7 because there are 7 days. Oh, sorry, no. I take this then 7. So you will get 819,000 Korean won. What about the transportation card? Well, there's two ways. You can buy a 1 day pass, or you can and a 2 3 day passes, or you can buy a 5 day pass and a 3 day pass. And which one is the better deal? It seems to be that the 3 day plus the 5 day is a better deal. So 3 day pass plus 5 day pass. Equals to current one of 75,000. One can verify if you want. You can write down 1 day plus 3 day plus 3 day equals to then you calculate how much this is, which is 15,000 plus 30,500 times 2, which is 76,000. So it's a 1,001 difference, not a lot. Honestly, not a very big difference. But this is the better deal. To be very honest, it's a very small difference. Because you know the Korean won and Singapore dollar is like a very small exchange rate, so it doesn't actually matter that much. But in the grand scheme of things, but we'll just take it as 75,000. So 7.5% goods and service tax. Total after tax. So now you add the cost up. So 420,000 plus 819,000 plus 75,000, and then multiply that entire thing by 107.5%. Okay. And you will get Korean won of 141. That's right, 1,412,550. Okay. And oh god, Microsoft Edge, what's happening to you? Okay. Oh, what's happening to my monitor? I don't even know. Okay, so finally we need to convert this to Singapore dollars. So we are trying to, so we need to buy Korean won. We need to buy Korean won based on Singapore dollars. So you can buy 1,000 South Korean won with 0.909 Singapore dollars. So SGD. Oh, okay, yeah, definitely my pen is doing something weird now. Not sure what it is, but never mind. I'll see what happens when I fix it later. Okay, so oh, it fixed itself. Okay, interesting. Singapore dollars will be, you take 1412550, you convert it into the units, which is divide by 1,000. Then you multiply by 0.909 because that's what we are buying. We are buying the Korean won based on our Singapore dollar. So we get equals to 1,284.01 2dp. Okay, so therefore I would actually justify bringing a bit more. So I think many of y'all will realize that you want to bring a bit more than this. So most of you will put 1,300 maybe. So personally I will put 1,500. Okay, so estimate costs of $1,300 plus $200 emergency. In case of emergency, you have an additional $200 with you. This is what I think. Yeah. So I would say 1,500. But you, of course, it's an open-ended, so let me know what you guys think. And that will be it for the Methodist Girls Paper 2. All the best to the O-level students taking the E-Math paper 2 tomorrow, and in the coming days I should be going back to A-level papers for the time being until A-Math paper. I'll be able to do one more A-Math paper before the A-Math O-levels, because I already did the ASS Barker one. Okay, so take care now, and I'll see you next time. Thank you.